Hello, I'm Cadmiel Martin, and this is my Term 2 project for Computech 2021 to 22, and it's an autonomous police vehicle system. But before I get to work, I wanted to document where I'm at so far. So this is Roblox, and I'll just click start. This is the car. It's an endorsed Roblox car. And there are the police vehicles over there at the back. They should get working. Yep. Oh no, kind of get running. Yeah, these vehicles deploy some rudimentary collision avoidance, but I noticed that they're a bit too fast sometimes. Yeah, I'm gonna just quickly... Yeah, they fail to avoid obstacles sometimes, but that's the issues with these high-speed vehicles. But so far, let's get... Yeah. Turns out, not fun not AI only problems. So this city map wasn't actually made by me, but that's not the point of this. It's just to test the AI vehicles, not to show off a nice city. As you can see over here, I'm just running away, and yeah, the police vehicles they have their collision avoidance gives them some kind of pathfinding, but I'm probably gonna need to implement some kind of A-star on them. And yeah, I seem to have lost them. Oh no, siren! Oh no! Wow, that was unexpected. Yeah, they'll need to avoid that better. Oh no, they found me. Let's go. Okay, yeah. Sometimes they get a bit ahead of themselves. They're trying to chase a point ahead of me. Yeah. Okay. So right now, he's gonna try to do a pit maneuver on me. I'm probably gonna lose him in the trees. There. Let's go. Let's go. Haha. You can't get me. You can't avoid trees. I'm probably safe. Oh no. There they are. I'll need to turn up the graphics quality a bit here. There. Oh no. That's them. Oh, whoa. Whoa. Yeah, they can use some tactics, I can see that. They can use simple tactics, but I'm gonna get away, haha. These guys are not the best drivers. This is version 5 of my AIs, but I've never... I had a version 6, but I forgot to save it. So this is the latest I can show right now. So far they use a simple... Okay. Yeah, I'm gonna stop that for now. Yeah, so I'm gonna try to demonstrate how their collision avoidance works. So here we are in studio. We have our AI vehicles here, and this is the same map that we saw earlier. This is the vehicle that I use. It's in a raycast folder. I'll explain that in a minute. But here are the officers. They're like this when you're not actively chasing them. This is not their original appearance. They actually originally looked like, at least this vehicle. It looked originally like this, but as you can see, I edited the appearance quite a bit. But yeah, so each vehicle is a model. It has animations, bindable events, constraints, effects, remotes, and scripts. And it has a controller script. It's not in the scripts folder. I disabled the vehicle script so that you can't drive these vehicles to try to get away from themselves, I guess. So they also have like, two submodels, body and chassis. Body is just what you see so that it looks nice and not awful. Chassis is what actually makes the vehicle drive. It's pretty much invisible except if you go here. That metal block, I guess, is the floor panel. That's what it's called in here. Let's see. Yep, floor panel. But I have two events, set humanoid target and toggle ignition. And set humanoid target, when I fire it with code, it just sets whatever this vehicle is gonna chase, and it has the test script. It doesn't actually do much. It's just a simple script that I use to get it to chase me whenever my character loads. But most of the code is in the controller program. So at the top I get services, I get the car, so that I can reference everything in it. I get some modules that are in here. I get chassis and effects. These others are only used when you're actually interacting with the vehicle as a player, but but this script is not a player, it only needs to interact with chassis and effects. I have an effects instance, which just calls an object-oriented instance from the effects module. And then raycast params is a data type that's used for the collision avoidance with raycasting. Here I set the collision avoidance parameters properties, I guess. Here are some internal variables, and then here are a bunch of internal variables. Here I declare a bunch of functions, and then I have update throttle to speed, face steer to position. These are all a bunch of internal functions. This is the pit maneuver function. It gets the nearest seat, and then it just steers into the direction of the said seat, and then it tries to do a pit maneuver on the vehicle. Here is where I actually start doing things, and then I just set this to initialize driving values so that the car's properties, these are still usable. They will be updated by chassis variable here. And I connect an event handler to run service.heartbeat. It runs every frame. I got run service at the top to keep with Roblox programming conventions. And then here is most of the programming. It's 245 lines. No. Until 219 is the event handler. So it's exactly 99 lines of code. So if the ignition and we have a target humanoid, then we get the target humanoid's root part. And then if the car is stuck, we'll reverse a bit and then set our steer to be straight. And then we set then if we're not stuck, we just set our vehicles internal variable here to detect whether it's stuck to 0, so, meaning it's not stuck at all. So if we're less than 34 studs to our target, we stop completely. And then here is most of the steering behavior. If we're more than 25 studs away from our target, then if raycast to point, this means essentially that can we see the target? If yes, then we'll just drive straight to the target, and then we won't use any collision avoidance because we can see our target fine. And then we'll update our throttle with compensation here, just using a function that we defined earlier. And then this is if raycast to point ahead of the vehicle is good. Otherwise, if you can't go ahead of the vehicle, then we will just go just go to the vehicle to the target. And then if target humanoid.seek part confined first ancestor, then this line checks if the target is in a car, then we'll attempt to do a pit maneuver on them. As you can see here, and then here is if we cannot go either directly to or ahead of the target, we'll go this raycasts directly in front, right to the right, to the left, and behind the vehicle. So essentially, it'll cast here, 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 and here. The respective vectors multiplied by the raycast distance. I've set it to 5,000, the maximum allowable for raycast vectors in Roblox. And based on that, we'll take do a bunch of collision avoidance stuff. Like here, we'll get the distance, And then here we will actually start taking action against to stop to I don't know get to try not to crash into things, I guess. And then this conditional, it's if ignition and not target humanoid, if we don't have anything, if our car is not turned on and we don't have any targets, or we don't have any targets, then we will completely stop. And then here I just connected the events in the car that I set here, set humanoid target and toggle ignition. And then this task.spawn function, it just creates a new thread which handles the emergency lighting system here. And that's where I am at so far with the AIs. The SUV does the same things, okay? That has no effect. But yeah, now I'm gonna need to improve on this. So the first thing I'm gonna want to do on here is probably get a better map. So I'll get back to you with a better map that, I don't know, looks better, that we can use to do something with, so that not just like chasing you for absolutely no reason. Hold on. Okay, so here on Studio I've built a small map. It's not the best map. It's still pretty small, but I'll improve it. I'll just focus on the car first. This is the car that we'll be using instead of the endorsed Roblox chassis. We'll be using a more realistic A chassis. It is super realistic. Just take my word for it. Search up A chassis in the toolbox. Let's see how to use A chassis programmatically, because normally it's used by players. But we'll need to run some code on it to get it to work with non-players and NPCs. Okay, give me a bit there. Here it is. So let's check the Dodge Charger. So that's what it's called here. Our body, no, it's wheels. We'll go to FL. It looks like they use an AV, body angular velocity. Let's open up all the other wheels. They all have the AV here. So it looks okay. So let's check these. So they all use a body angular velocity here. So that means maybe if we set this to 5, that means that set makes it go forward, but it doesn't actually quite make it go forward because, for example, if we want to make it rotate, it won't go straight. It'll keep going in the direction that it wanted to originally. It'll keep going that way until it falls off of the world. It won't actually turn. Okay, let's stop that. But what we can do is we can take a consistent vector. We can make it so that it'll keep the car going, the angular velocity spinning relative forward compared to the wheel. So I'll get back to you after I've made that. Hold on. Hello, and 2 days later, and I finally figured out an interface for my Dodge Charger. It's based on a couple events here. These provide an interface to control the car. I have a script here called controller. I will document this upon release. I hope so. I hope that I remember to do that. I haven't added support yet for the ELS on event. I also will hope to do that eventually. But this is what I have so far. Let's run the place. Give me a bit here. So what essentially does, it has a couple variables. setting the current steer and the current speed and the relative steer angle of the car. Every heartbeat or every frame, it sets that to what it should be right to her currently. So we have our car set up. I actually had to switch out the A chassis version. I was having some problems with it, and I never actually got around to doing the OLP based module, but I find this will work. But let's type a bit of code to test this. So workspace.rivercitypd. Let's try new speed. Then we'll fire this. We pass a number argument, let's say like 30. And there goes our charger going yeah, it's gonna cross our little bridge here. Then it's gonna go off the map, probably. New steer angle colon fire 30. I just set our charger speed, our steer angle to 30 degrees, and now our vehicle is now stuck in a circle. It's going 30 degrees on its steer, and it'll keep doing this until I reset it to something maybe like possibly like 20. Look at that. The circle's smaller now. Let's see what happens when we straighten this. 20. So we can partially control the car. Yeah, it fell into the water. But yeah, that's the interface that I have so far to control the vehicle. And I was using a command prompt, but it should work identically in a script. So, yeah. So, let's get the car to work with this guy. Let's see if we can get this to work with it. So, I wanted to actually be able to drive properly. Like, not just go in a straight line, ramming into maybe any random building that it sees fit. But yeah, I'll get back to you when I have an actual map to work with, I hope. Here's our map for the project. It's pretty small and simple. There's our charger, it's supposed to chase us. And here's our getaway car. Let's get in. Okay, let's go back in. Okay, we'll shift into gear. Third gear. Okay, so we have a button in the corner, and that's gonna call the police on us for no reason at all. Let's go. There, they have it following us. Has no real collision avoidance on the system. Okay, that was fast. Hold on. Yeah, we're gonna go flipping a bit. But yeah, I don't think it's gonna work very well here. There, it's working. There, that's better. Yeah, but the charger is very fast on us. Okay, it really likes doing that. So, before I start implementing actual collision avoidance, I want to see what we're up against on here. Hold on. Here, it's a game that also uses pursuit technology for the police vehicles. And to test this, let's go out and get them to chase me. Let's go real quickly. Okay, let me lower my graphics quality, so yeah, let's just set it to that. Graphics quality here won't matter much. Okay, then. Okay. Hold on.
Ako ba nung last year,
do something like
section ako sa mata, 150.
and then they'll start chasing us. We'll get to see how their pursuit tactics work. There, they're next to us.
Retinal bleeding.
What? Hold on, that didn't work out.
Nagkaroon.
Yeah, they're not
Hindi
the
pa
best
po.
drivers.
Hindi na natin kung may concern naman daw sabi, pero
Looks like they're going after.
sa derma, sa derma. Sa telasma.
Okay, let's do this real quickly.
Oh, pero flat
There. Now we should be chased. We'll just get to see how well used their tactics are. Okay, so we'll dismiss that. Okay, so we have some on-foot officers. Those are irrelevant to our testing. Okay, we hear the sirens. They should be around the corner somewhere.
Fatty liver.
Yeah, we're escaping. Oh no.
In-explain na ng doktor sa akin.
Oh no.
It's a symptom of fatty liver. Kaya binigyan ako ng supplement for fatty liver. And then,
oh no. It's the car.
Lipotrophic factors.
Here they are. Let's go.
Hindi po.
Okay, yeah, they have a tendency to hop out their vehicles too early, but yeah, they got me there. I think. There. Okay, so that's where it is, but that wasn't a real pursuit, so let's wait to get out of here. Let's wait real quick and then we'll be able to get out. Hold on.
I'll just give you supplements, sabi niya. Tapos, sabi niya, just
go back.
Sa mga health stores, for fatty liver.
Let's get an SUV again. Our car.
Bigyan niya ako lipotrophic factors. At saka, supplement lang po. Yeah, for the liver, for liver health. Tapos, kasi nung time na yun, mataas yung cholesterol. Tapos, nito nung November, nilodge ako. Sabi nung bago ko
then we'll spawn in SUV. There. Let's do something a bit more serious, just for testing.
Opo. Yeah.
Okay, by the way, these vehicles are using the official Roblox chassis. It isn't the best, but it has some nice realistic physics. So this game's using that. Let's do that. Okay, this will be more serious. Okay. No, it's not too serious. Okay, wait, you can hear the sirens there. Oh, whoa. I didn't expect them there. Okay, they're coming. Come on. I need some vehicles. Come on, vehicles.
Si Mami daw, sabi niya,
let's go.
Natatapos lang ng blood test ni Mami, sabi ng doktor, everything's normal. Kaya tuwa si Mami. Tapos nag-lose pa siya ng 10 pounds.
So, okay, there. We have a chase.
Ano po?
There. Okay. The collision avoidance doesn't work very well here. It uses some simple raycasting. Okay, there. It's going into the tunnel. It's gonna start chasing us. Let's go.
Dati niyang 7.4, parang naging 6 point, sabi niya, 3, gano'n.
Okay. The reason for the glitchy physics is because the vehicles are owned by the server, the AIs, but my vehicle is owned by me, so there's a slight network delay, but it's working well so far. There, we have a chase. Okay. Yep, avoid that. Let's get more people chasing us. Okay, so yeah, that's how pursuit here goes. For another sample, let's go to a different game and let's see what they have to offer. Here is a different game. It's called Vehicle Simulator. This is supposedly the best pursuit AI. It uses neural networks. So let's see how that goes, how that went for them in this game. Maybe we can get something from their implementation. I'm also planning to use neural networks someday. Unsure when that'll be. This is a big game, so it's pretty laggy. I have decimated the render distance. Okay, there. We've triggered them.
Actually, yung converge mo, lumabas ng
There, that's the police vehicles.
kaya cheaper. Mas mura siya. At least maganda dito, sir. Kasi ka-start lang po. Hindi maganda yung service kahit kanya. Mura pa siya. Yeah. Ang problema, hindi lang dumating dun sa banda namin.
So we can see it avoids obstacles a lot better, maybe because this is a much larger map.
May mga signal na pwede. O may makakakuha ng wifi, ano? May free wifi ba dyan? Nasa hinggang ko wala pong wifi. Malakas po signal pero walang wifi. Walang wifi. Kailangan bumili ng pocket wifi or mobile data.
Okay, it's definitely... Okay, we haven't gotten it to chase us so much yet. Oh, there it is. It's much better at off-road.
Router. Yeah. Oo, sa tissue. Ay, o sige. Salamat sa iyo. Jayan, kumusta ka na? Kuya, salamat kayo oo nga, nakakatuwa naman.
Okay, so I think we have a pretty good idea of what we're up against here. Okay, so here's my project inside the testing location in the actual production environment. Here are officers right here, and they're inside there having fun. Okay, so what we're now gonna do is get into our car. And this, hold on. Okay, now they're chasing me. I'm gonna get running. Okay, well, we're lagging a lot. Okay, so you can see that the handle turns pretty okay. Well, better than I was hoping. Okay, so here they are. So you can see they're actually pretty okay at this. They're just a bit aggressive. Okay, that's unexpected. Okay, so I lost it. Okay, so that's where I'm at right now. And that was my term 2 project. Okay, thanks for watching. I don't know what I'm supposed to say at this point. So what I think I learned from this, well, honestly, I can admit that I think that these cars are performing worse than in the last iteration. So I guess what I can infer from here is I'm actually nearing the capabilities of conventional AI. I'm gonna need to do a different approach soon. Yeah, like probably gonna need to do something different for the next iteration. Yeah, or maybe it's just not this night. I don't know. So yeah, that is my project so far. I think that's where it is right now. Thanks for watching, I think. Yes, I think my next project I'll have to do some neural networks. Okay, thanks for watching.